Let's see if the stream is up and running. Just double checking that everything works. Looks to be okay. Yep, mouse is moving, I'm audible. There we go. Okay. So we're going to chill a little until I'd say like for another 9 minutes, so that people are here and can let me adjust the music a little so that we can start the presentation with so that everyone is on the same page. Where they are, that's where we look at that. Okay. Got myself some coffee, got myself some water. I am ready. Oh yeah, you're right, Yadik. 1 second. Wait, I did link it. Open up a new Firefox tab and have the screen running on a second monitor, just so that I can have a look at it from time to time. One more thing I want to do. Okay. So I think we'll wait until 5 after 5 p.m., which is in 3 minutes, and then I'll give a short demonstration of the game we're going to code in case anyone doesn't know it yet, and then we're going to get ready to start developing it. It shouldn't take too long. This will probably be the shortest of the streams of this kind. I'd say that it's probably implementable in an hour, maybe around that time. I'd say we just roll with whatever comes up after. But the next games will probably be more, let's call it extensive. So this is kind of a test run to just see how things go, whether people are interested in it, and so on and so forth. Wait, there it is. Okay. Wait, Yadik, am I being shown as streaming on Discord for you? Doesn't show it for me. Wasn't there a way you can manually toggle it on? I thought so. I can connect my Twitch account. I don't think that's the same thing. Usually it turns on automatically. I think it just didn't this time. There's streamer mode. Enable streamer mode. I'm just completely blind. I'm sorry. Right, okay. Let's get started. Everyone who joins afterwards will just have to wait. Or what game are you making? Yes, that's what we are gonna start with. So the game we'll create today is 2048. It's a very small game. It's very light, so ideal for our starting conditions. In case you don't know what it is, you have a little board out of 16 cells, which are arranged in a 4x4 grid. And the way you play is that you have 4 controls. You can move up, down, left, and right. And if you move in either direction, all the tiles are going to go in that direction as far as I can. So right now we have a 2 in this tile. And if I now press up, this 2 is going to fly all the way. Oh, I probably need to activate the game. This 2 is going to fly all the way up here. Now every time I perform a move, no matter in which direction, in a random new tile, in a random new slot, a new tile spawns, and these tiles can have values of 2 or 4. And the interesting, called interesting part is that if you have 2 tiles with the same value and 1 tile would go on top of it, they merge together into the next highest tile. So now we have a 2 here and we have a 2 here, and if I merge that we get a 4 and the browser crashes. Okay, never mind. And then we get a 4. Now we have 2 4s next to each other, and if I press the right button they merge into an 8. Each time a merge occurs, the score is updated by a specific amount, which is equal to the newly merged tile, I believe. The game is very simple. I'm not a huge fan of it. It's mostly just a time sink. I've played it a couple of times. I'm not that good at it. And the titular name 2084 comes from the fact that if you continue this process, you will go from 8 to 16, and then after some time you'll have 32. And you can just play this really fast if you want. It's not the ideal kind of play, but yeah. 64, 128, so on and so forth until you reach 2048. So that is 2 to the power of 11. So you have to perform 11 levels of merges, so to speak. I've never managed it. I think my high score is with like one tile of 1024 and 1 tile of 512, and then I failed. You lose the game if all tiles are occupied and you no longer have a move option. So if I'm just going to spam some things, at one point or another we'll end up in something like this, where no matter which direction I move, I cannot perform another merge, and the entire board is full, so there cannot be any more spawns. And when the board is full and you cannot move in any other direction, you lose the game. And that's it. That's the entire premise of it. So we are going to implement that in Graphite. I've already set up everything that we need to have set up. So right now, if I just demonstrate how this, what this looks like if I run it, it's just an empty window with Graphite 2048 as the title and nothing being displayed. So we're going to change that by first creating a background. Now a background is just a box with a color. So we're going to create a new box. Maybe I should zoom in a little so you can see the text better. Now we're just going to give that the ID background, and we're going to initialize it. Now the box really doesn't need a lot, so we can just set the background to be some color. So as an example, if I just set the color to be, this is RGBA, so this would be red, which will be very unpleasant to look at. So let's make that a little less red, and perhaps add a little blue so it's a little more purple. Now if we run that, we'll have the entire screen covered with a specific color, unless I messed something up, which I hopefully didn't. And now we have this nice purple background as the color. Now, of course, if we look back at the game, which I don't have open anymore, so I'm just going to open it again. So we need a grid of 4 by 4 different tiles, and these tiles can be either filled or empty. So that's the next thing we do. We're going to represent the state that our game has. I'm going to keep this window somewhere. I'll just put it over here. Right. You don't see that. You don't need to see where I put my windows. That's my privacy. So the next thing I want to do is I want to have some kind of data that I can persist. So now we have a board, and we're going to make it customizable, how many columns and how many rows there are. And I'm making this, in case you're not that familiar with C++, I'm making this a const expr because I want to use these values as the initialization for the internal representation of the grid. So the grid itself is just a collection of data. Now this is called an array, but you can just read it as a list, which will contain something, which we're just gonna write here. And then it has columns times rows of that something, which I'm going to call slots. Now, we also need to specify what a slot is. So we're just going to do that here. And then we can say that our list consists of slots, and the amount of slots that it consists of is columns times rows, which I'm also going to put up here. Oh, that's the wrong operator. Columns times rows. And we're going to put that here. And I'm sorry, I have to clear my throat every now and then when I talk this much, so I will mute myself when that happens. Now we have this board, and right now we have 16 slots. And each slot is going to have a value, or well, maybe it's going to have a value. So we're going to make that optional because it can be either empty or not. And that is also going to contain an integer, like an int value. So we are going to just say that. Now, that already is pretty good, but we also need to have an actual board. Like this just declares the layout of a board, what it's going to look like. But we need to have an actual board for our game. So I'm just going to create one here and default initialize it. And then let's just give the 5th slot a value of 5, just for demonstration purposes. Now, in this box, we now want to kind of align our things in a grid. Now, if you think back to what the actual game looked like, you had a grid of the boxes which are all equally sized. So what we're going to do is we're going to, first of all, I need the DOM be able to access it. I want to, in the future, I want to just pass the DOM here. It's a really simple fix, but I just didn't do it yet. And we're going to have a grid layout, which I'm going to call, let's call that board grid. And we're going to initialize that as well. Now we have 4 columns and 4 rows. So what we're going to do is we're going to have column info. Oh. And we're going to have row info for each of these things so that we can represent the size of them. Now this is very trivial because they're all the same size. There's nothing special going on. You just divide the space up into equal sizes. So for each column that we want to have, if only I could type, we're going to create a new column with the values 0%. So if we want to make this more explicit, but right now it works this way. If you pass a value that is smaller or equal to 1.0, it's interpreted as a percentage of the whole. So we want to tell each column that it will want 100% of the total size. And then since they all have the same pressure, they all get the same size. I could just make this like this, which would be, I guess, technically more correct, but I don't care about it. So that's all the columns we want, but now, of course, we also need all the rows. So what we're also going to do is for each of the rows, we're going to create one that we want with the same values. And then we assign the columns to the grid, like so. You can also move them so that we don't have an additional copy, since we don't need them afterwards. And we also set the rows like this. Now, just to make sure that this already works, we're going to draw some debug lines, which will show us the way the grid looks right now. Oh, I forgot I still have the very not pretty purple going on in the background. At least it's not bright mode, right? Because light attracts bugs. Okay, so now as you can see, we've now divided up the grid into this kind of layout. Now the grid has a default spacing and a default margin on the top and left, right and bottom side. But as you can see, if I resize that, they all get an equal size of what they of the available size, which is exactly what we want. Well, one way or another. Okay, so now we can get rid of this debug call and get into the meat of things, because now we want to draw our slots. So we start at we iterate over the amount of columns we want. So we go from 0 to columns minus 1, which is exactly columns iterations. And then a second time through all the rows we have so that we're actually iterating over a grid. Now this is similar to how you would iterate a two-dimensional array. Now we only use one array because, I don't know, for convenience, I guess. I also realized that this is wrong. And thank you very much, Clang, for telling me that it's wrong, because I would not have realized that otherwise, and it would have been very shameful, especially with all these people watching. Both of them. Okay, so now we will need the index of in some situations, so we can just get the index by this little calculation, which is if we iterate over the rows. Actually, I kind of want to go rows first, and then go into the columns later, so that we go left to right and then one step down instead of top to bottom and then one step right, which I hope makes sense, but I can show you that in a moment. Now for each thing that we want, we need to have, if you recall, some kind of tile. And now this I'm going to represent with a button that just doesn't do anything if you click it, because, you know, it looks the same way as a button would. It has a background, it has a label. So we're going to use that by creating a button for each of the things. And as the ID, we pass the index so that they all have a different ID, since the index is unique to the grid. And then we initialize the button as follows. Yeah, this is already pretty okay. Just as a debug, I'm going to set the text to be the index. Now this is just a very complicated looking way of saying just set the text to be equal to the index, because C++. But another thing we need to do is we need to tell the button where it is in the grid. So we set the column index and we set the row index. The row was I because we iterated the rows up here, and the columns were J because we iterate them with the J. And if I'm not mistaken, that should go left to right with a bunch of buttons in a grid. Compiling is fun. There we go. So now we have a bunch of very ugly buttons in a grid, and they're all aligned at the top left, which is not what we want. So let's change two things about this. The first thing I want to change is the alignment, and I want to tell it that it should take our alignment enum and start at the center horizontally and at the center vertically. Additionally, I want to tell the button to just fill the entire width it's given. So we're going to take the min width and set that to 1.0, and the min height as well. If you recall, 1.0 means 100% of the thing you have available. Now this will look a lot better, I hope. There we go, much better. So we go left to right, 0, 1, 2, 3. That is just showcasing the index right now. Okay, and this also all sizes automatically, so there's no problem here. This is exactly what we want. But of course, now we need to actually display the values. So, buffering for someone else quite frequently. Huh. Would that be an issue with me, or is it just Twitch things or your internet potentially? If anyone else is watching and you have buffering issues, please tell. And if you don't, also please tell. Could be, I mean, it could be anyone. Maybe do a speed test, I guess. I don't want to do one while I'm streaming. I don't. All right, that's a plus. It's 2 versus 1 yard. You lose. Okay, so now we don't want to just set the text to be equal to the index, because we don't, like, the user doesn't care about the index. The user cares about the values. The values of the society that is the board. So we're going to say that the slot is the board slots at the index, and if the slot value exists, then we put a string that is equal to the slot's value, like so. Now this reads weirdly. Value.hasValue is a little odd to read. So What is a good name for this? I always struggle with this stuff. We could call it value opt to delineate that it's an optional. Now I'm just going to. Am I? Yeah, I'm just going to leave it for now. If anyone has an idea, do tell. So now what this will do is, because we only set the value for the 5th slot, this will only showcase one number, but the rest will still have their background rendered. What does optional do? Yeah, 1 second. I'll get to that. So now, as you can see, 1, 2, 3, 4, 5. Well, I guess we're counting at 0, so 0, 1, 2, 3, 4, 5. Only the 5th one has a value, and that value is 5, which I probably should have made differently so that it's a bit clearer. So let's just recompile that for a moment. I really need a better CPU. Anyway, so now we can see that the value is being displayed with our beautiful ping in the background. Now, optional indicates that there are 2 possible scenarios. Either a slot has a value, in which case the value is indicated by a number, which is a uint32, which stands for a number that is positive and uses 32 bits to be represented in memory. But there could also be a case where there is no value in the slot. That is why it's optional for the slot to have a value. It does not have to have one. If we look back at the picture here, now a slot could either be empty, in which case it does not have a value. The value isn't simply 0, the value just doesn't exist, or it could have a value, in which case it's delineated as such. So that's the first thing we do. We set the text if there is a value in a specific slot. But another thing we want to do is we kind of want to change the background for the specific value that we have. So we are going to need, if you recall with this game, the colors change the more merges we get going in the end. So if you can, we start with a sort of light blue, go up to a darker blue, then a really like, I don't know, this is like navy blue, I guess. This is, I don't know what this is, like beige orange, then this is normal orange, and oh, did I crash my browser again? Yeah, I think it just can't deal with this. There we go. Didn't focus. Okay, and then it goes to an even darker orange, which is almost brown, I guess. Which doesn't exist, but yeah. So, to do that, we're going to create a color table. And we're going to make it an unordered map. So a mapping from a specific value to a specific color. Now the GLM U8 Vic4, that's just an RGBA color. It reads a little different. If it helps you, I can do this like so. Maybe that's easier for people to read. So we want to start at 0, which will be the value we use for an empty slot, and this is supposed to be, I don't know, I'm not good at picking colors, so let's just kind of copy what DuckDuckGo did. So we use like a light blue-ish, this thing that looks good, right? Can I? This, I think it's this, so I'm just gonna say that you stay above others. There we go. Okay, now I can click here without it going away. So that's like 100, 140, and 200. That's the initial value. Then we're gonna have one value for 2, which is going to be slightly darker. So that's like 90, 130, and 220. 4 will be even darker. Go with this. Actually, come to think of it, I think the value for 0 should be gray, because that's what they did as well. So we're going to move that one down, and then the value for the 8. Okay, that window management is pretty ruffle. Hey, dude, it does the job, right? Never touch a running system. Always rewrite it. Okay, so we're going with something even darker here, which is like 70, 120, and 225. Something like that. and the initial value was supposed to be gray, so we're just going to make it as such. We'll make that 170 across the board. And of course, all these values need to have an opacity as well, and they're all supposed to be fully opaque, and now it should not give us an error anymore. So what we're going to do next is assign that, oh, I did an oopsie. There we go. Assign that to the background color of the button. So we're going to say set background, which will be a solid fill. So we could specify a linear gradient here as well. And we're going to take the color table and we're going to specify that we want the slot value or 0. So as for the default, we just take the 0 color in the color table, which is the gray that we chose. So now what should happen is the same as before, but this time the slot which has a value will have a different color, and the slots which don't will be gray, if everything went to plan. There we go, beautiful. Although I'm not really happy with this because, I know why. Now we didn't code anything for 25, if you remember the color table, we stopped at 8. Actually 25 is in the power of 2, so we would never hit it. So this is just transparent because it's the default, so we're not going to make that 25, we're going to make that 8 to showcase it a little better. There we go. Now we got a little, nice little light blue, and or I guess this is the darker blue was supposed to be, and then the light gray for the other colors. I also kind of want to get rid of the background being so ugly, so I'm just going to say that the background will be what I usually use for a darker gray background, 22 across the board, apart from the opacity. There we go. Now this looks a little more... This looks a little better. I'm not 100% happy about the spacing and the margins here, so I'm just going to tell the grid to shove it. Well, not quite. I'm going to tell the grid to use a little more margins, or have the margins be a little bigger with like 10.0, and the spacing... I like it when the spacing is equal to the margin. I think that gives it a nice uniform look. So we're going to basically double what we had before. The default is 5. And that looks a little better as far as I'm concerned. Although, does anybody else have this illusion where you see like little squares in between here? I forgot what the name of the illusion is. It's when you have a bunch of round things and then you see the little dots in between. I'm not sure how to get rid of that, I'm gonna be honest. So you will just have to deal with it. All of us suffer through it together. Okay, so that's basically it for the representation of the board, right? There's pretty much nothing else to do apart from adding new colors, which we will do eventually. But for now, I would like to add some interaction to the game. So the first thing we'll have to do is we're going to put the interaction handling all the way up here before we start the actual rendering. So for every frame, we will have a bool that says move taken. And if the move was taken, we're going to go through the board. So I'm going to do something that every C++ developer will hate me for. I'm going to use rand. Now that is very evil, as everybody will tell you, because if you use rand, then your PC will catch fire and 12 kitten die, which is very sad. However, I'm going to do it here because I am not going to bother with standard random generators just for this demonstration. So if a move was taken, we're going to generate, this is also very evil, using an unbound while loop, but yeah. We're going to take a specific index, which is going to be anywhere from 0 to the number of slots we have, and if the board's slots at the specific index value has value, then we can... I'm kind of thinking maybe I'll just use standard optional here That would make it a little, then I could write something like this, which is a bit better. Anyway, I'm just gonna keep it for now. Naming doesn't matter anyway. And if it has a value already, we actually we do it this way. If it doesn't have a value, then we give it a value equals. Now again, this is very evil. I'm just gonna make a little flip-flop sample thing. Then we'll either assign 2 or 4 to the value. Oh, right, I need to take this. And I need to make this a question mark, because I'm very confused. So, if the move was taken, we just go through the thing so long until we find an empty square, and if we can put an empty square there, then we will. So, now we need to figure out when a move was taken. So we're just going to take a move right now whenever the left key. Actually, let's use WASD, right? We're gamers here, capital G. So if the window has the A key pressed, then actually no, I can't do this. I can't do this. If it has the left key pressed, which is the arrow buttons, then we're going to take a move for that specific frame. And that should generate a new value on an already empty slot. However, it will crash if we already have a full board, because then the while loop will never end. So now we've got the default with the 8, and now if I press the left button, it will generate a new 2. If I press the left button again, a new 2. A 4 might appear every once in a while, again it's random, and at one point the entire board will be filled, and if I now press the button again, we will have the program freeze, which I do not want to do. Considering fail and victory conditions is an entirely different story. I mean, maybe we'll tackle it now, right? It's got to be done eventually anyway. No, I'm not going to do that. So, if the Windows button is pressed, not the Windows button, the left button is pressed, but we also need to consider the other 4 options, which is going to the right, going up, and, oh, actually, I think that's literally called up, and going down. Now, if I press any of these buttons, the move will be taken and a new thing will be generated. But before we do that with the, like, taking or generating a new thing, all the previous squares need to be moved. Now, there's a few different ways we can approach this, and I'm not sure if there's like a standardized ISO version of 2048 that you can 100% be certain to use the correct algorithm. So we're just going to use our own algorithm by just taking a look at the way this was implemented in DuckDuckGo. But before we're going to do that, I'm going to dip for 5 minutes-ish, and I'll be right back. So I'm just going to put a comment here for everybody else. And then I'll see you guys in 3 to 5 minutes, I guess. Enjoy the music. I'm going to turn it up a little. Okay, hello, I'm back. So that was a quick 5 minutes, I guess. We have snow outside, it's so beautiful, you should see it. We didn't have snow in like 8 years. Okay, so we stopped at trying to figure out how to exactly approach different aspects of the game. And now we are just going to take a look at what happens in specific situations. So, as we've already established, if I press a button and go in a specific direction, the tile will go into that direction until it hits the end. And what the end is kind of depends on the situation. Now, normally, the end is just the end of the board. If you would only ever have one tile, then you would just like be able to just walk around, like so. But you can have situations where that's not the case. So as we've established, if two tiles merge together, then you can move on top of the other tile to merge with it. But you cannot merge with a tile that is of a different value than you. So we have a 4 here and we have a 2 here. And if I move to the right now, the 2 is going to stop here. Now this all seems very trivial to us, but it's exactly what we're going to have to code. There's one more scenario that we need to kind of get to, I guess. Okay, so I'm just going to use this scenario. So what we'll see in this specific situation is if I go to the right, then this 4 and this 4 and this 4, they could merge in different ways. We could have this 4 merge with this 4, or we could have this 4 merge with this 4. And more importantly, if this 4 merges with this 4, we could theoretically also merge this then 8 with this 8. Let's see what DuckDuckGo does. So what DuckDuckGo does is it merges the thing on the right first, but it doesn't merge it more than once. If something has been merged once, it needs to be merged in the next move. So this doesn't propagate, which I guess could be an interesting mechanic for like a different implementation of the game, but we're trying to be traditional here. So I can of course just merge it with another move, but that would already generate a new thing, filling the board up more. And that's exactly what we're trying to implement now. Now there's a few pitfalls here, which is mostly that you don't want to allow double merges, which is very unfortunate. And you don't want to allow, or you want to specifically merge from the direction that you're moving to the other direction. So if there's two kind of ways you can merge, then you always want to take the one that is further in the direction that you were moving to. So if we press right, it should be further to the right. If we press up, it should be further up, and so on and so forth. Just going to move that to the side again. And we're going to take a look at how we can do that. Now, one thing we always need to do is we need to iterate through every single slot in the entire grid. So, oh, by the way, I'm not sure if we'll actually have animations. Like if you look at DuckDuckGo, this like moves up a little and has some sweet little animations. I'm not sure if we'll have that. We'll have to look how things go, because the animation framework it used to work in the old system, but now after before we made the announcement, there was a little rewrite of different things to this DOM-like approach, which is similar to how HTML would do it, and it's very hard to get the animation system to be compatible with that. Not because it's hard to get the animation system right, but it's hard to get the way the programmer interacts with it right. So if we press left, then we're going column by column, right? If I press left, then we want to check this column first, then this column, then this column, and this column. And technically speaking, we can skip the first column because, you know, it can't go further left than it already is. So we can start at 1. And then we want to go all the way up to the amount of columns we have. And then for each column, we want to go through all the rows within the column. And in this case, we really do want to go through all the rows. And we're going to just do the most trivial thing that we can do, which is move the things to the left. This would be the most trivial implementation, I guess. So we're going to take the current slot, which is going to be the moving slot, to be equal to the index, which we're going to calculate real quick. Equals j times rows plus I. Oh, not I. Sorry, it's supposed to be idx. And we're going to take the board slots like this, and now we have a reference to the slot that we want to move. Now, we need to go backwards, so we go to the left. So we start at the current column, which is equal to I, and while the current column is larger than or equal to 0, we go to the left. So we start at like 2, and then we go to 1, 0, and at 0 we stop. So what we do here is we're going to say current slot. So we're also going to do this. Target slot is what we're going to choose. Actually, like so. And then we're going to say that if the you know what, let's provide a helper function here. Oh, hello, Matsudamusiak. Hi. We're going to provide a helper function here, which just gets a slot at the row and at the column. So this just returns slots at row times rows plus column, and has like a little assert here for the row to be smaller than the rows, and another from the column to be smaller than the amount of columns we have. Otherwise we would go out of bounds. Okay. Oh, this is supposed to be a J, of course. Is this right? Yeah, this is right. Okay. So in this situation, we're going to get rid of this and then just say board.get at J and at I. And here we're going to say current equals board.get J and at column, like so. And now if the current slot has a value, and actually we can just make it different. If the current slot's value equals, which includes a check for whether it even has a value, the moving slot, like so. Also, we're going to quickly do the moving slot has a value, because if it does not have a value, then we do not need to check it. We do not care. So in that case, we can just continue. Like so. And if the current value slot is equal to the moving slot's value, so this is a check. Sorry, I think this is... this needs to be different. If it has a value, and the value is... Okay, 1 second. I'm gonna formulate this out a little. If the current slot has a value, then, like the one we're looking at, we can merge with it if it has the same value as we do. So we do another check here. Current.value.value, which is still, it reads very weird. I'm just gonna change this 1 second. Like so. Where are we at? There we at. Type def standard optional UN32 slot. There we go. And now we can write things a little prettier. Just gonna take a little bit of refactoring. Look much better, right? Much better. Okay. So now with this, with the new syntax, we can take, if it has a value and that value is equal to the moving slot's value, in that case we can merge it so that the current value plus equals the moving, actually this is just equal to multiplying it by 2, and else we need to use the previous slot to be the one that we would like to have. So in that situation, Do the shift operator, it looks sexy. Like this, right? I think I'm not mistaken here. So we're gonna keep it readable for our users. So now I'm just kind of thinking that it would make sense to target slot equals current. Let's do it like this. This makes more sense. And else we break from the for loop, because that means we should go to the previous one. And if it does not have a value, then the target slot also becomes current, like so. So we can break this down a little better. I'm just going to keep it like this. It's very readable. And then now what we do is if the target slot has a value, then we're going to say the target slot's value times equals 2, and the moving slot's value equals 0. Actually, we can just do it like that. But there needs to be one different thing. If the target slot equals the moving slot, then the movement failed, because, you know, you can't, if it didn't move at all, then you don't want to change anything. So this should already work, I believe. Let's see what we got. Let's see what we got. Compiling is still fun. Okay, so now you go to the left. You don't. Do I crash? You do nothing. You probably crash, right? But where do you crash? Start at 1, go to columns. Start at 0, go to rows. Proper increment. Let's just see if we actually reach that point. That's probably a silly mistake somewhere, to be honest. Okay. No, that was actually pretty fucking stupid. Because we can't read that. This we can read. So now we'll see if it actually gets there after we press the button, or if we froze. Okay. Yeah, we're freezing. You see the number doesn't increment anymore. So somewhere up here, we reach a point where we... Oh, god damn it, I hate when I do that. We reach a point where we're simply not moving forward anymore. Now, the question is, where does that happen? And I believe the issue that we have is that we were using unsigned integers, and this overwraps at the negative amount and then goes to like a 4 billion number, and which, you know, never stops, because then we start iterating down from 4 billion, which isn't really what we want to do. And now I'm going to press the button and still nothing happens. So let's get our little check here again. Like so. I'm actually going to leave that in for a bit. Okay, we still freeze. I'm not quite sure why we freeze this time, because now with the integers being taken, there should not be any problem. Let's quickly see if we freeze like this, which part actually causes the freeze, because it shouldn't be this part, right? Like, this is like a very short iteration through a loop. Okay. So now this works again. So the freeze happens somewhere here. And I'm probably just being silly. We start at I, which is the column that we're at, and we're going down to the, well, first column. And we do that until, oh, yeah. This is why you make sure you read your correct column, like your correct loop iteration values, whatever you want to call it. I compared to I instead of comparing to column. Silly mistake. I blame someone else who wants to play victim. Okay, so things happen, but they don't happen the way we want them to happen. And we also want to, that's one issue I do have, we don't want to make this 0, we want to reset it so that it becomes nothing again. Okay, so you see the merging happened on here. Something is really not right. As you can see, something is just completely funny. But there was some merging going on, so I appreciate that. The problem I have now is to figure out why exactly this fails, and I really hate warnings. So, shut up. And 32, there we go. So the problem would be where exactly. So this takes the row first and the column second, and it multiplies the row by the number of columns. That's probably the problem we had, right? Okay, so it was definitely a problem, but like as you can see, they merge properly now. So the movement doesn't work, but the merging does work, which is interesting. We're making progress, slowly but steadily. The question is, why does the move not work? So we start a specific column, we stay in the same row, we get the current iteration, like the slot at the current iteration, and we should probably start at -1. Because we don't want to ever care about ourselves, and this will never be below 0 because we start at 1, so this will be fine. And then we get the slot there, and if the slot has a value and that value is the current value, then we assign the target slot. Otherwise, but we should break either way. That's an important one. And if it does not have a value, then the target slot becomes the current value. And at the end of it all, if the target slot is not equal to the moving slot, which is what we start at, which we assign it here, so if it never gets reset, then yeah, that should do the trick. And if it has a value, we multiply the target slot value like that, and otherwise we just oh, I see one issue. This is definitely one of the issues we had. We didn't assign values to any empty slot that we would move to. So that is probably why the moving looked so funky, because it didn't actually move, it just generated new ones and then cleared the old one. Okay, so this is good. We had a bad optional axis. I see why. That was just a silly syntax, API usage mistake, I guess. Incompatible. Oh, right. My bad. Okay, now let's see if this works. I hope it does, because then we got this figured out. Partially, there's still one problem, but... Okay, so now we duplicated it, which isn't supposed to happen. But why did we duplicate it? We do reset it down here. And it's a reference as well. So, do we return a reference? We do return a reference. I mean, reset, you should set it to be a null opt, so I don't see how that fails. I do not see how that fails. Same problem as before. I mean, it does do something, right? I guess. So certain things work, but for some reason it duplicates the initial value. Oh, the 2 here. That won't make a difference, will it? Oh no. Oh no, it will, because I assign this every frame. I'm an idiot. So we're going to we are going to make a new function here. And we're going to put this function right here, like so. There you go. And move taken, now called board generate new value. And the board will now be initialized a little differently so that we can initialize it once. Like so. And this needs to be called now, because it's a static value, the initialization will only happen once, which means that we don't have the issue that we had beforehand. But now the code should work. If I just recompile it for another 50 minutes. Okay, so just put a 2 there. Now we're gonna move the 4 here, and it spawned a 2 there. We can only move to the left right now, which is a little unfortunate. And now this should merge, exactly. And now... it's really hard to play this game if you can only move in one direction. Okay, so these 2 merged. This will merge, and I think we game over here. Yeah, nothing else will happen anymore. We'll still have to figure out how to track game over. But now this will be a little hacky, because you could make this a little more generic by specifying the increment for each specific step. But that's for losers, so we're just going to copy and paste everything. Now moving to the right works in the exact opposite way that you would move in the left, where you start at columns -1. And I believe I need to cast this as well. Actually, we start at column -2, and then we go into negative increments, and this will do the exact opposite as well. We'll start at I+1, make sure that column is smaller than columns -1, and we'll do ++ call and do a static cast in 32 here, like that. And now we should be able to move both left and right. Isn't that exciting? So, move to the right, and it didn't work. I know why it didn't work, because I'm putting a -1 here like a fucking idiot. Okay, so now I can move this to the right. There we go. I can move this to the right, to the left again, spawned up here, the right again, the left again, the right again, left, right, left, right, left, right, left, right, right. Beautiful, and we lost. And I crashed the program because we still don't have a victory condition. Now, of course, horizontal movement is all fine and dandy. Also, I apologize for the bells, but I can't do anything about them. But what about vertical movement, though? Wouldn't that be fun to have? Now, vertical movement is actually pretty easy, but before we do that, I want to have a few more colors. What kind of colors would you guys want? We could go... Oh, what am I doing wrong? Where's the... Oh, that's what I'm doing wrong. Nope. No. No. I'm stupid. Why am I? That's why am I. There we go. Now it's fixed. So we'll need a few more colors. I'm gonna open the color picker again. Now this DuckDuckGo goes into the yellow direction. Now I'm personally not a huge fan of yellow, no offense. So we're gonna go to the purple direction, which I think is much more appropriate. So we're going to color, not color. Camel. Yeah, wait. I did say color. It says color here as well. Who are you fronting, man? Okay, so 180 and 230 is the one we're gonna use for 16. 230, and then we're gonna go a little darker for the next one, which is 32. Next one's 64, which is gonna be 80, 50 without the backslash, and 220. And the next iteration will be even darker, like so. And we're gonna make that a 6. Oh, sorry, not this one. This can stay 64. Thank you very much. 60, 40, and 200, roughly. And now, how do we test this? Well, I guess we test it by actually being able to play the game. So I'm just going to quickly make sure that we are able to move up and down by continuing to copy paste everything. Just not something you should do, kids. Don't try this at home. So we're gonna do this step now, and upwards movement starts at the first row, goes all the way to the bottom row, and then we also want to switch this around like so. I'm gonna hopefully not shoot myself in the foot by being a little bit pedantic here, and actually rewrite that, change it a little in that direction. You're gonna rename this to row, and then it starts at row and J, like so. And you are going up, is that right? No, you're going down, and that's better. That's exactly what I want you to do. So this should be upwards movement, and now we're gonna go for downwards movement, which is exciting and so different from the rest. With downwards movement, we start at rows -2. We could start at rows -1, but the first row would really not do anything because it cannot move further down. And we do this until this is larger or equal to 0. We iterate in the negative direction. This now starts at rows minus... Wait, am I an idiot? I'm probably an idiot. This one starts at +1, right. And it iterates all the way down up to static cast in 32 rows. Like so, and this should be I, not J. And I think that's it. Let's see. Let us see. Already streaming an hour, so maybe the estimate of an hour wasn't great, because we still need to do some... I mean, we're not far away. Basically, we still need to cover for double merging, and we need to cover for... whatchamacallit, for victory and losing conditions. So now I can move up. No, I cannot. I cannot move up. Why not? Because I start at 1 and go all the way up to rows, which is correct. Also iterate through rows first. And then I go through all the columns in that row. And I get the correct position from the row and the column. Doesn't have a value, we continue. And then I take the row that I'm at, go 1 row before it, and see if I can go there. And this should be I. Same issue as before. I fixed it down there, I didn't fix it up here, which is, you know, stupid. It's very stupid. Okay, fingers crossed, drum roll. Bam, look at that. Now we can happily move in all directions. Isn't that beautiful? We also got 16, 32 as a color. And look, I'm winning. Look, Mom. I guess. And 128 doesn't have a hard-coded color for it yet. So we need to think about colors for 128. We've gotten to the part. Thanks, Dad. This means so much to me. Let's go. 128, 256. Now these need to be special colors, because if you make it all the way up here, then you need to feel like you just won the Olympics. No, that's wrong. Okay, so we got these more colors to fill out, and I should probably stop copying these lines because I'm clearly not intelligent enough to fix them afterwards. Right? Oh, right. Nice, okay. So we got these filled out. Let's just double check. 128, 256, 512, 124, and 248. That looks fine and dandy. Now we stopped at this purple color. Now I'm saying we go to pink. That's my hunch. But I'm always up for suggestions. So let's 128 is already a pretty big achievement. It's not, by the way, but we're gonna pretend it is. So that's 150 to 50 to 200, and I'm gonna go for the next one. We're gonna go even pinker, right? I don't know what to do with the colors, man. I really don't like the colors I'm choosing right now, but we can always overwrite them. We have a color table, so it's really easy to change them if we feel like it. And then the pinkest of the bunch. I don't know if this is even differentiable on my screen, honestly. Like a 255. So just, I'm not sure if you can even get up there quickly enough, because there's still an issue we need to fix. Also the random generation, I'm pretty sure most browsers, like most applications, will use some kind of improved random algorithm that isn't totally random, because I think that would just mostly break your neck. Can I get rid of the 8 there? I can. Very good. Now in the process of doing that, I fucked up everything else. Not having any animations makes it really hard to track what's actually happening. I'm gonna admit that. So props to the people who figured out that animations are a good thing. So we're 120. I think this color scheme isn't the worst I've ever made, right? I mean, if you look at the initial Ikarus versions, those look so much worse. Can I can, right, okay. So this is fine. I'm okay with this. Now let's see. I don't think we'll make it to 256 because, yeah, we already lost. So we're going to spawn different things here. I'm going to start spawning at like 64 and 128 to make it a little easier to get up there. It's not cheating, technically, because I call it debugging. It doesn't matter that I get the high score. I'm always not anxious that when I mute myself to clear my throat that I forget to unmute myself and you're all just looking at silence. Oh, look how good I am at this game, man. Nobody can like... I think the difference between 512 and 256 is really not noticeable enough. And then for some reason 124 is... I don't know. Did we forget to assign colors? Or is that just... Am I just being silly? Nah, we forgot to assign colors. Okay, so the pink isn't really noticeable enough anymore. So I think we're gonna go to like a sweet cyan for this one. Open up a whole new base of operations for the last value here, which would be 90, 220, and 230. And then the next one... Actually, I think I kind of want to go to with like a little less... saturated color. Move up a little to 75, 210, and 220, and then the last one will be really saturated so that we can hopefully see a difference to the previous one at 225 and 240. Okay, let's try that again. Nice weather we're having, eh? Okay, so little head start. Now 512 is a different color. I don't think the I must say I don't think the transition from pink to turquoise or cyan or whatever you want to call it is quite right enough. Like, I like the colors generally. There's just no real consistency when we go from one to the other, but I'm not quite sure where to go. I guess we could go to red from pink. Maybe that makes more sense actually. So let's go to 230, 20, and 130. And then instead of going up the value, we're going up the or I guess down the saturation, so 240, 20, and 80. And then we're gonna go to like a really, really red. Like the kind of red that Quentin Tarantino would use for the blood in his movies. Okay, let's see how this looks. So I like this. I like this transition. I don't like this transition. I did something wrong there. Why is 500? Oh, I don't think that's supposed to be 320. But I also don't know if it's supposed to be that either. So 230, 20, and 130. That's fine, actually. Maybe it was just the 320 that made it too purple, I guess. Okay, try that again. Nice. This is the color I was going for. This looks good. I appreciate this. And I completely deadlocked myself. So let's try to... There we go. Guess we could distinguish it a little more on this front. Go down in steps of this. And let's try that again. Just a little fine tuning here. You want to appeal to the mobile users. I'm good. I think this is a decent color scheme. It's not ideal, I suppose, but it's... I'm happy with this. If you reach 248, you're supposed to win immediately anyway, so I don't think it's that much of a big deal, that the color is really like piercing in your eyes. So I'm good with this, I guess. The next things we're going to need to add is first the victory and losing condition, which the victory condition is really easy. So we're going to create a new enum, and we're going to call that like game state, and we can have running, lost, and won. Those are the three states we're going to have, and each board is going to have a game state, which is going to be default initialized to red.state equals running. And now what we do is in our render queue, which is down here, we're going to only render this if the board's state equals game state running. Like so. And otherwise, if the board's state is 1, and otherwise if the board state is lost, and otherwise we have some kind of issue in our code. I guess we could do a switch statement here to make it a little more conceptually sound. But in this situation, what we're going to do is we're just going to have a label. I hope this works. I'm not actually sure if the label will fill the screen the way I want it to. Victory label. Now this is going to be initialized like so. Label set text. You won. You're a winner. And that's it. And then the other one is just you lose. Suck it. Yeah, I think we'll have the lose label a lot more often because I just, you know, I'm just not that good. Now checking for victory is really easy. And now checking for victory is going to happen. Oh, this should be game state running. Checking for victory is going to happen here. Check game state like so. We're going to have check victory and check loss as separate functions. Now the victory is very easy. You just check whether any of the numbers is 2048. So we can also make that adjustable. So we can say that UN32 target victory number equals 2048. And what we do here is we go through all the slots. We're gonna call this update game state actually. And if the slot's value if the slot equals target victory number, we return true, and otherwise we return false. Now the loss is a lot more difficult. What's your problem? Reference to local variable declaring an enclosed lambda expression. What kind of lambda expression am I in here? Oh, that's the problem. I see. So now this will simply do two things. It will if check victory state state equals game state 1, and then we return here, and otherwise if check loss state equals game state lost, and then we return here. I guess we don't need this return, and we could technically also do it like this, which, you know, whatever. Pick your poison, return false, so that we don't have undefined behavior, at least for the moment. It's always boring when you don't have any undefined behavior, right? Imagine if your code just worked the way you wanted it to. So we're going to just fold these code regions so that it's a lot easier for me to scroll down. That was on accident. I wanted to fold it up here. There we go. Makes it easier to just maneuver through our code, unless Qt Creator decides to spasm out. Okay, and then at the end of this all, we're going to board update game state. Now this should already allow us to lose the game, which is really nice. Additionally, what's happening? Why am I scrolling 4 billion lines every time I scroll? Do I want to know? I probably don't want to know. Anyway, so this should only really happen when the board state is running, because otherwise we're not supposed to take any inputs anymore. Otherwise we can get back to the situation where we have lost the game and we continue putting inputs in and then just, you know, get into endless loops. So I'm just gonna lose as quickly as I can, which is easiest achieved if you go up once. Actually, we don't have a lost condition yet, so I'm gonna win as quickly as I can. It's a lot more, you won, you're a winner. Look at me, guys. Oh my god, can somebody screenshot this or like make a clip or whatever it's called on the Twitch? This is, oh my god, look at this. This is so amazing. Woo. Okay, never mind the fact that that was cheated. Now, the much more difficult situation is checking for whether we have lost the game. Now, I know how to do this, but it's going to be a little more convoluted. Now, we need to check the neighbors. Specifically, we need to check whether any specific slot is not, like if there's any slot that is free, then the game is always playable. If all slots are occupied, so that's the first check we do, if all slots are occupied, then that's the only situation in which we can actually have a lose. But all slots being occupied doesn't mean we have to have lost. There are situations in which we could have won, or like can even do a move still, not won, even though all slots are occupied, because you can still merge things. Now, if slot has value, return false, because in this situation, like we're already out of the danger zone. Now, check neighbors is going to be a little more interesting. So we take in a slot like this, and we're going to take in the column, the row, and the column of the slot. And so what this will have to do is it's going to check all the neighbors of that specific slot and see if we can merge with it. So now we're going to say if row not equals 0, then we have to check the same slot but one up. So if we are here, then we need to check this slot. Slot upper equals and then we go into board. Guess I should capture that here. Board dot, actually no, I just need to capture this because we are inside the function. Then we go into slots No, wait. What was the function called? Get. Very simple. I like it. Row -1, column. If upper. Let's make this function specific. So I'll just move this away again. Let's make this function return a boolean. If upper equals slot, return true. We're going to return true if there is a possible place for this. If row not equals rows -1, we're going to check the same one with row +1. Right. Neighbor. Upper neighbor. Make it a little more explicit. And then we're going to do the same with the column. By the way, if you've noticed any slowdown in the application, the reason for that is that I'm compiling with a lot of debug stuff to analyze memory and shit, so Graphite is nowhere near this slow normally. Like you saw that after we got a loss, it took like half a second to actually show a victory. It took like half a second to show the victory stream. This is not normally the case. Like this is instant in normal Graphite, but right now, again, I'm using a bunch of debugging stuff. So I have address sanitizers, I have undefined behavior sanitizers and memory sanitizers and debug symbols and all that good stuff. So that's because I'm still in the development environment, not in the environment that the user would actually end up with. So if column not equals 0, we're going to check the left neighbor, which is going to check at the column like that. And if wait, no, this is not this is the bottom or lower neighbor. Is there like a word for lower but for right, like writer neighbor? Is that a thing? I don't think so. And this needs to check columns -1. Otherwise, we return false. Now, for each slot, in the slots, if check neighbor, actually, we gotta do this differently. For UN32, I equals 0, I smaller than rows, plus I, if for UN32 j equals 0, j smaller columns, plus j, if check neighbor get ij, return false, because then we have a possible move, otherwise we return true. There we go. And this should now be able to detect whether we are in a state where the game is lost. Let's see if it does. That might take a while to get to a position where we actually lose the game. So another thing we kind of need to check is right now if I press up and nothing happens, it still generates a new thing that's normally not supposed to be in this game. So we're just going to spam a bunch of shit. Oh, right, I should probably get back to generating. Sorry, I had to clear my throat again. I should probably go back to generating a little more sensible numbers so that we don't ruin immediately. And any minute now, there we go. Bada bing, bada boom, bada bing, bada boom, bada bing, bada boom. You can say a lot of things about our lack of animation, but it does allow you to play this game super duper fast. Okay, so I still have possible merges, but the game crashed. And that is because we're gonna just move that around here. Bool is full. Actually, what happened here? How did it crash? Because that should never happen. It should never be at a full board. And then I guess we update the game state before we do all the interactions so that we cannot have any interaction happening in a frame where we would already have lost, and then it tries to generate something along those lines, I guess. So let's try to get in a lost situation again. Hopefully this time it doesn't crash. Man, it's really hard to lose. Not lost. Wait, was that lost? Damn it. You know what? I am going to... render this anyway. Again, what's happening? Please stop. What the fuck am I looking at? What are you doing? Just... maybe I need to restart it. It's really acting up. It's never done this before. So again, just close this. Get rid of the thing here. Please don't break my code. Thank you. And then in this situation, what we're going to do is we're going to take a box, ID overlay, and initialize that. Box force pose 0, 0. Box force size. Window get size. Box set background. Graph solid fill, like, I don't know, like 140, 100, let's get like 150. Well, let's choose the background color for consistency. And make it like 25% transparent. Like so. And we're gonna have the same here. That way I can... look at the board to see if we actually lost or if I just messed up. Good. Now to recompile. Actually, I'm not sure if that works. I've never forced positions like that before. Okay, so. Bada bing, bada boom, just spam a bunch of shit. It's so much easier to lose when I normally play the game. Okay, so it crashed again. It's not supposed to happen. I would like to get to the losing screen before I figure out what the crash does. Okay, so it crashed again. How does that happen? Okay, so let's get to a point where almost the entire board is full and then fill it. And now it crashed. No, it didn't. Now it crashed. Why? I mean, there's gotta be... I know why, but it's just... Generate new value. Let's not make that while it's true. Let's check if the board is full and then... If slot has value... Bool found equals true. Equals false. Found equals true. If not found, return. I don't know why it even gets into this loop. It shouldn't, but this should fix it. There we go, this should fix it. Okay. This should be a lost game, right? There's no more merges I can do. Okay, so it didn't freeze. That's good. But I cannot merge, and it thinks that I haven't lost. Why? Why does it not think I have lost? Doesn't even get here. It should, right? It definitely should. I don't think it is. No, we'll see. I faded. Okay, so it does check that, but it never really gets into the position where it thinks that I lost. Why not? Okay, so it's still printing, but I cannot move anymore. So it still gets in here, but then it doesn't check it properly, I guess. So one more time. That is the row we pass in. Is that correct? I, rows, J, columns, get at the I and J, and then pass in row and the column. Yeah, that's correct. And if it returns true, then that's true. Upper at row, column, and line. And then right, left, lower. Okay, so it found something at right. Found something at right, that's also correct. Okay. Now it doesn't find anything. It also doesn't... What? No, it doesn't find anything, but it returns... It's fine if it returns none, it's just... Did I check the state wrong, perhaps? Perhaps I'm not updating the state correctly. No, this should work. Move it there, doesn't really matter. For consistency, I guess. If state equals lost equals 1. Curious. Okay, so now we do return true on losing. So I guess the state is being updated to being lost. Where's the state changed? It works when I set it to 1, it just doesn't work when I set it to lost. Maybe this is the problem. I guess. It's not. It is else. Like it didn't win. We'll need to go into there. I don't know. I do not know. At least I found out a quick way to lose. Nope, still not. It's probably just a very simple mistake that I made that I'm currently overlooking. Must be. Yeah, so it did switch to... It does get here. Jesus Christ, not again. Cute, please. Don't do this to me. So it does get here. Just doesn't display it. Am I an idiot? Probably am an idiot, actually. Put that here. Should be better. Yeah, I think it was when I detected the victory condition, I didn't have this new system in place, so I falsely assumed that the new system would work. So I did correctly check whether we won or lost, but I didn't correctly check whether the overlay works, which it apparently doesn't. I think the reason is that... God damn it, this is so confusing. I don't know why this is happening. Please stop. Thank you. I probably need to put it in here so that it actually has a parent. Again, what are you doing? This is honestly, like, I've been using this for months on end and it never happened to me. Okay, so let's just make this capture everything. And you go here. Now this should work, if I'm not mistaken. I probably should change the text color to be black. Come to think of it. There you go. You lose, suck it. I want the opacity to go a little higher. Let's go for 96. 96, like so. I also want this to be a little darker, so like 130. And I also want the labeled color to be black. Set text color 000255. There we go. Again, I seriously, I'm so confused. There we go. Let's check whether we can lose. This is a correct loss, right? I'm still not happy with the opacity. So make this like 100. Let's go in the opposite direction, maybe. Maybe 25% wasn't right. Maybe it's 100, like 75%. That's more correct or better to play with. So 75% of 256 would be 64 times 3, so 196. Oh wait, that can't be right. 128, 192. This is why you calculate things instead of just guessing what they are. Ah, my coffee's gone cold. I think Faded will hate me for drinking cold coffee. There we go, much better. I like the background music. Thank you. Okay, is that a correct loss? That looks like a correct loss to me. I'm still not 100% happy with the opacity. It's better, I guess, but the label size isn't correct, and the reason for that is pretty simple. So set font, and then we're going to go dom get font duplicate with size, and let's get like 48 here. I would also like it to be bold, but I don't want to load a second font here right now. Real dom cannot be captured. That's right. Now you can be captured. No non-conversion. Wait, what? Not again. Please. Please stop. No non-conversion from graph font to const graph font. Wait. Really? Duplicate with size returns a normal object? Taking the object of a temporary file. I mean, I can easily just change it right now to allow it to specify the font size instead of just being able to specify the font, but I'm lazy, so bigger font equals get current font, duplicate with size 48. There we go. Much better. Label set font. It's a bit weird that we return temporary though, because we technically all store all fonts in the font manager. So we should be able to just return a reference so that we can take the address of the reference. Okay, one more time. Let's fail as quick as we can. I'm good at that. There we go. I like this. This is much better. Like a bigger font, centered still, around the baseline, and I think this looks good. I think I'm very happy with this right now. So that is like 98% of the game. There's 2 more things I guess we could implement, but that kind of depends on whether you guys want me to go to that length, because it's very boring. Like it doesn't add much to playing the game at itself. I can just play around normally, I guess. So the 3 things, while I talk about this, the 3 things that would need to be implemented as a remainder would be animations, which is really not that easy to implement. I think I just saw a bug there, actually. To implement would be animations. Then I don't know what to call this actually, double merge. I don't think we allow double merge because of the algorithm we have. So that is already taken care of. And then I had one more issue which I found. I even announced it in the stream. I kind of forgot what it was. Probably not important if I forgot it, right? I guess we can track the score, right? That would be a bit interesting. So we can. Oh, Jesus, I'm gonna restart this. This is annoying. Let's open that up. Go to 2048 main, and we're going to put the grid layout in another grid layout, which is going to this is no longer. Maybe the bug is because I folded this. Maybe it just doesn't deal well with that, which I guess could explain it. Maybe. Anyway, we're going to put a bigger grid layout around the board, and I don't know if this works actually. We've not really done many testing with nested layouts for now. And so this will contain the normal grid. Sure. And it will also have 2 columns. No, 1 column. Set columns 0.0, 1.0, 1.0. That's 1 too many, like so. And I should probably call it properly. And then the rows, we have 2. The first one is going to auto size, and the second one is going to take whatever it can get from the remaining space, like this. And then grid set column in row index equals 1. And we're gonna have a little label here. Label ID score label, graph label, and we're going to initialize it. Set font bigger. Font, I believe I declared it further down, so let's move that up here. All the way up here to all the other static stuff. And go back to where we were, and you take the bigger font without the H and set text board dot score, and then we're gonna ICU Unicode string from UTF-8 that with standard 2 string of the score itself, which of course doesn't exist right now. What happened? Did it work? I think it worked. Right? That text 1, 2, missing 1 bracket. And now we're gonna add the score member to the board. Urin32 score. Gonna initialize it to be 0. And we're going to then sport.score plus equal target slot value. Put that here. Put that here. So whenever a slot gets merged, it increases the score by the value of the final result of the merge. Like so. And if I'm not mistaken, that should already work. However, I do not know if the label is default centered. We're gonna need to look at that. Let's hope it works actually. No, it's not default centered. So we go into the score label, which is up here, and we're gonna say label set text alignment, enum value graph alignment, h center, v center, like so. What appears to be the problem, officer? Huh. I think I know what it is. Min width. Right? Fill the entire width, please, is what the problem was. Very nice. So now when we merge things, the score goes up and we can actually kind of get points, I guess, really quickly, because this is a much better implementation than any other implementation you've ever seen before. Does it work? Let's see if we can get a merge. So we have 8 and 8. So I think it merged by 2 things there. So now 2 and 2 should, yeah, increase by 4. And we still have the unnecessary print statements. Boom. Yeah, I guess this is playable already. I don't want to get rid of the print statements, which were all the way up here. And now that's fixed. So with this done, I guess we can make the score label a little prettier by going here and saying score plus. That work out of the box? I think it does. Ah, it works. Look, nice. I think we can call this a functioning game. The only thing that's really missing is, I guess maybe there's like a bug or two in the application. I've not really tested it a lot, and because of the lack of animation, it's really hard to actually see whether or not there are any issues that go on with the game itself. But this is what I would call a functioning 2048 experience to play the game. It's a little hard to track if you're just looking at it because you don't see any animations, but I am pressing the buttons so you don't know what is actually happening, which disconnects the game from your brain. I know that because it sometimes happened to me when I look at videos where the same thing happens. But yeah, I think this is a pretty good start for what I had in mind with this series, where every week we try to code a little game. Now this took me 2 hours. Ish. With the break, it's like more than it's around 1.5 hours, 1:45, due to the delay at the start and the fact that I had a little break between it all. But I know there's not many people in chat, and I think most of you are my friends. But if anyone is in there that is, I guess not my friend would be a little mean, but is not personally acquainted with me, I would appreciate any kind of feedback. You don't have to write it here. You can. It's probably better if you write it on the Ikarus server or open something on Steam. You can, of course, just write something here if you care about it. I'm probably still going to do this every week because I really enjoy this, and even if nobody would watch it, it's just fun to actually see my creation work. Like when you develop something, usually you only just checking that my mic is on. Usually you only really like test smaller stuff and you never really see it in action, and this just makes me happy to see just how far really we've come with what we want to do. I don't think I will be implementing the animation system simply because like I could just hard code it the way it would be. It's rather simple. You just interpolate between the, like you have like a movement vector for all of the things, and until the movement vector is reset at the end of the movement, you do not process any further input. Actually, you know what, guys? You know what? Let's do it. Let's go. Or do we do it? No, let's not do it. I guess I don't really see the point in it. It will be a lot easier if we have the animation system set up, if we get around to that. It's not a huge priority right now. And again, it's mostly like the animation system still stands. We can still have all kinds of animations. It's just the interface, like the way I would actually code it, that doesn't work right now. So yeah, this is what I'll leave off with. Today we have this as our final result, and I think that's pretty neat, pretty nifty. It's a very small implementation of a very small game, and I'm doing horrible right now. I'm just spamming buttons, really. Yeah, this is what we can leave off with. Score of 1444. It's a beautiful date or number. And I'll just leave this as it is. And if anyone is interested, I can upload it as a demo. Will be open source soon enough, so you can just look at it anyway. But we could like upload an executable of this if you really care. And yeah, thank you all for chiming in, tuning in, and hopefully I will see you alongside some other people next week, where I will be looking at a different game, something like Pac-Man, Tetris, whatever. I'm open for suggestions. Okay, until then, and have a nice evening. Bye bye.